Hello and welcome to our lesson on multiplication and division. So we're going to talk about some properties of multiplication that we're going to see come up, and then one property of division that's important to know, and then we'll jump right into the multiplication and division itself. So first off, we have what we call the identity property of multiplication. An identity property means you're doing something to a number and not changing it so that you get back the number itself. It maintains its identity. And with multiplication, the only number you can multiply by without changing a number's value is 1. So the identity property of multiplication states that multiplying any number by 1 does not change its value. So for instance, 5 times 1 is going to keep us with a 5. Negative 12 times 1 is going to keep us with a negative 12. Or even in algebra, multiplying something like x or any term by 1 maintains its value, so x times 1 would still be x. Okay? Then we have the multiplicative property of 0, which basically states what happens anytime we multiply a number by 0. So the product of any number and 0 is going to be 0. So 5 times 0 is, I was about to put 5 there. 5 times 0 is going to be 0. Negative 12 times 0 is going to be 0. And x times 0 is going to be 0. So 1 is the identity for multiplication. It's what we can multiply by without changing its value. And then 0 times anything makes 0. Now the third one we're going to talk about here is not really a property with a special name. Is just kind of a nice to know thing. But the product of a number and its reciprocal, is always 1. So if you haven't heard that word reciprocal in a while, reciprocal is just flipping the numerator and denominator. So the numerator becomes the denominator becomes the numerator. You flip a fraction to make its reciprocal. So you can see right here, 3 over 4, the reciprocal would be 4 over 3. What happens every time we multiply a number by its reciprocal is we will end up with 1. So you have 1 over 2. If you multiply it by its reciprocal, which would be 2 over 1, multiplying straight across the top we get 2, straight across the bottom we get 2, and of course 2 divided by 2 is going to be 1. Same thing is going to happen here, or any time you multiply a number by its reciprocal. So 4 times 3 is 12 on the top, 4 times 3 is 12 on the bottom, and of course 12 divided by 12 makes 1. And that would apply to algebraic expressions as well. Division, the only property we really need to be worried about is division by 0. Okay, division by 0 actually cannot happen. It is not defined. So any fraction that begins with a 0 in the denominator, or that results, like maybe we perform some operations and the result is a 0 in the denominator, that type of fraction is said to be undefined. We have not defined in the mathematical world division by 0. It's not something that exists or can happen. So 5 divided by 0, which by the way is the same thing as 5 over 0 like this. So our fraction bar and division mean the same thing. In either case, it is not defined for us. We're going to say it is undefined. And if you put it into your calculator, oh, I don't have my calculator ready. Give me a second here. Calculator, come on. What is it doing? Oh my gosh, guys, I'm so sorry. There we go. My fat fingers can't manage all the time. Sorry. So if we put this into the calculator, we try to divide 5 by 0, it's going to tell us that it is not defined. Some of your calculators, not Desmos, might say there's an error, because in fact there is an error. We can't do it. So again, x divided by 0, that is the same thing as x over 0. Doesn't matter what is in our numerator, if there is a 0 in the denominator, it is not defined. So that is undefined. Okay, so whether it's numeric or algebraic. All right. Now, mathematical inverses, in the same way addition and subtraction are inverse or opposite operations, so are multiplication and division. So with addition, for instance, let's say we start with the number 10. If I was to add 2 to it, I would get 12. If I was to do the opposite, which is subtract 2, it would take me back to 10. So these two operations are opposites. They sort of undo one another and leave us back with the 10 that we started with. The same would be true for multiplication and division. They are opposites. So for instance, if I take 8 and I multiply it by 3, I end up with 24. If I take my 24 and then divide it by 3, then it takes me back to 8. So multiplying by 3 here and then dividing by 3 here, those two operations take me back to the number I started with because those two operations are opposites. Okay? Now, the rules for multiplying and dividing, there's some sign rules we want to be careful with. First of all, multiplication is commutative. We've talked about that. We can change the order in which we multiply and not change the value of our product. So again, 8 times 3 and 3 times 8, they're both 24, right? Division, however, not commutative. So when we have both operations present in one problem, the established order of operations is to work the division and multiplication from left to right, whatever happens first, left to right. So we work left to right with multiplication and or division, just whatever occurs first, we're working in order from left to right. Now when we're multiplying or dividing, the sign rules are the same. If you are multiplying or dividing numbers with the same signs, the two numbers that we are multiplying or two numbers we're dividing or whatever numbers we're, however many, multiplying or dividing have the same sign, the result is always going to be positive. So two negatives in a division or multiplication problem make a positive. Two positives in a division or multiplication problem make a positive. When you're multiplying or dividing numbers with different signs, then the result is going to always be a negative. Same sign. Sum, I like to remember when we're adding numbers with the same sign. And same sign, it's not really sum here, but if you think positive, that sort of works too. Different signs, difference, or negative in this case, okay? So, for example, if we have a positive 8 times a positive 3, we get a positive 24. Well, negative 8 times negative 3 is the same thing. They have the same sign, so we multiply to get a positive. Now, when they're different signs, we end up with a negative. So a negative 8 and a positive 3 is going to make a negative 24. And then here's the same thing. We're going to get a negative 24. And fortunately, the calculator could verify all that for us too. But division works the same way. So 10 divided by 2, which is the same thing as 10 over 2 like this. Two positives make a positive, so we get a 5. Negative 10 divided by negative 2, again, that's the same as this. Negative 10 over negative 2 still makes a positive. When they're different signs, like negative 10 and positive 2, or like 10 and negative 2, then we end up with a negative result. So a negative 5. And there it is. Okay, so that's the basics. Now let's see if we can't put a few of these things together. So multiplication, we're going to work from left to right. Although if it's all multiplication like it is here, it doesn't really matter the order we multiply. It's just a good habit to go left to right so that you don't forget when you get to division. But if you wanted to multiply out of order here, you absolutely could. So maybe you're looking at 5 and negative 2 and negative 5, making that a positive 10. And maybe you're looking here and seeing that that's 12, and then you want to multiply to make 120. However your brain is working, the order that you multiply doesn't matter. Just again, be careful when you have multiple operations. So I'm going to go ahead and go left to right just to stay organized here. So I'm going to multiply positive, negative. That's going to make a negative. 3 times 2, which makes 6. And I'm going to bring down the rest of this. And next here, negative's going to make a positive. 6 times 5 makes 30. And I didn't have to put that positive there, just so you were clear. And then I still have a 4 to bring down, so now I'm going to multiply here. Positive, positive makes a positive, and 30 times 4 is 120. So 120 is going to be there. Now, some of you might be questioning, in the addition and subtraction, we saw lots of parentheses like plus and minus 2 like this. When there is a symbol between your number and parentheses, like here there's a plus sign, or if there was a 3 minus a negative 2, whatever it is. If there is a symbol between a number and the parentheses, then we are performing that operation. So we are adding or we're subtracting. If there's no symbol between your number and your parentheses, then multiplication is implied. So like in this one, there's 3 and a negative 2, but there's nothing in between the parentheses and the number. That's multiplication there, okay? So make sure you're not seeing this and thinking, oh, we have to subtract. The number next to the parentheses is telling you to multiply, okay? And again, that could be confirmed with the calculator. So we are brushing up skills, but we can also use our technology. So if you wanted to plug all this in as is, actually try to type it in as is helpful, then you end up with the same answer. So you can verify your work there. And you might want to do that if you had these fractions and you don't like fractions. But I'm going to go left to right with this one as well. So positive negative is going to make a negative. Multiplying fractions is straight across. So 1 times 1 is going to be 1, and 2 times 3 is going to make 6. And then I'm going to bring down my 2/5 and my 4/3. And again, left to right here. So positive negative is going to make a negative. 1 times 2 is going to be 2, and 6 times 5 is going to make 30. And I'm going to bring down my 4/3. And one more time here. Positive negative makes a negative. 2 times 4 on the top is going to make 8. And 3 times 30 on the bottom is going to make 90. So right now we have negative 8 over 90. But that's going to reduce. We could say that the top of the fraction is really 2 times 4. And I know that the bottom I could say is 2 times 45. They're both even, so I knew they had that 2 in common. So I'm going to go ahead and reduce out that 2. So I'm going to have a negative 4/45. That's not going to reduce. And you might be wondering about the negative there. It doesn't really matter where we put it. So if you had negative 4, let's see, 4 divided by 45. If you put the negative on the top of the fraction, you get a negative result. If you decide to stick it on the bottom of the fraction, you get the same negative result. If you decide to stick it out in front of the fraction, it's still a negative. So it doesn't matter where you put it, just make sure that it's not in there multiple times, because what happens with the double negative is it makes a positive. Okay? So if you wanted to put a negative and then 4/45 like this, or 4 and then you wanted to put the negative with the 45, all of these three fractions are equivalent. So it's okay to move that negative around. We just don't want to put multiple negatives in there to cancel them out. All right, number 5. This doesn't look so bad. Got some division here. We got to remember the rule for dividing. Remember, we don't divide fractions. We technically multiply by the reciprocal. So we're going to make this a 2/3 times 3/2. And what happens when we multiply a number by its reciprocal? Well, the top becomes 6, the bottom becomes 6, and when we divide, we get a 1. The product of any number and its reciprocal is 1. It should also make sense if you're just thinking about this, right? You know, when you divide something by itself, like 3 divided by 3, you get 1, or 10 divided by 10, you get 1. If you have 2/3 divided by itself, it should make sense that that ends up being 1 as well. All right, next is where I see lots of mistakes happen. So be really careful. When you have multiplication and division in one problem, you have to work from left to right, okay? Left to right. And so we're going to go 12 times 3 first, which is 36. And let me stick with my organizational tool here. This is going to make 36. I'm going to bring down my divide and my 2 and my times 4. There's probably a lot of temptation to multiply the 2 and the 4, but we work from left to right. So the next step here is to do the 36 divided by 2. That's going to give me 18, and I bring down the times 4. Now I can multiply, and 18 times 4 is going to make 72, our final answer. Okay, and again, if you weren't sure, just put it in the calculator. It's going to tell you. So 12 times 3 divided by... that is not what I wanted to do. 2 parentheses 4. I wonder if I can make the division symbol in there. It's going to... No, it's not doing what I want it to do. Because if I put 2 and 4 here, it's going to group those. And that's not what I want. So the calculator is doing what people do. It's dividing by this whole quantity, which is not what we want. How can I type this in the calculator? I guess one piece at a time. That's tricky. I guess if you have a normal calculator that lets you do the divide instead of just making it a fraction automatically, that would be great. Oh man, I feel really bad that this can't go into the calculator because the calculator it's grouping these. What the calculator is doing, you saw it put all this together on the bottom of the fraction, so it grouped that, which is not what we want. Okay, when we get to order of operations, I can explain a little more. I don't want to get you too hung up on that for now. Just make sure you're working left to right, okay? Unless you have a calculator, we can type all that in one line. I would say don't trust it on that one. Goodness. Okay, we'll talk more about that in the next lesson, I promise. So let's go number 7. All multiplication, so technically the order doesn't matter, but if we go left to right on this, we're going to end up doing a little bit too much work. So we're going to get some number here when we multiply. Times 3 is going to be another number. Times 5 is going to be another number. But what's going to happen to that whole result if I multiply by 0? Well, the whole thing's going to 0 out. So if it's a big product but there's a 0 in there anywhere, then that whole product times 0 is going to end up being 0. So this is going to be some number times 0. Doesn't matter what the number is, we end up with a 0. So it's kind of a nice thing to notice. And then here, even if, again, we're going to go left to right here, doesn't matter, we're going to end up with division by 0. If we multiply 2 times 3, we get 6. Okay, so 6. And then if we bring down the 6 and multiply again, we get 36, but it doesn't matter because in the last step, we're dividing by 0, and 36 divided by 0 or 36 over 0, in either case, it's undefined. So that's division by 0, no good. Okay, where are we at here? All right, some exponential notation to finish off this lesson, because exponential notation is really just another way to multiply. Exponential notation is used to show how many times to multiply a number by itself. So for example, if we were looking at 3 times 3 times 3 times 3 times 3, if we're going to multiply 3 by itself 5 times, the shorter way to write this is using exponential notation. So this would be 3 to the 5th power. Okay, so the 5th power there, again, this is called a power, or an exponent, is telling us to multiply our base of 3 by itself 5 times. All right? So when you see something like 2 to the 5th power, it means take 2 and multiply it by itself 5 times. So 2 times 2 times 2 times 2 times 2. So it's 2 to the 5th power, 2 times 2 times 2 times 2 times 2, 5 times. Or we could say that this has a value of 32. And here, negative 5 being cubed means to multiply negative 5 by itself 3 times. So take the base, multiply by itself 3 times. So according to the exponent, that's how many times you multiply it by itself. And so we have, in this case, turn my pen on, we got 25 here. And then when we multiply by the other negative 5, we end up with negative 125 for our result. Let me move that. Kind of a handy tool, huh, to be able to just move your work. Let's see, negative 10 squared. This means we're going to be multiplying negative 10 by itself twice. So the base 2 times, and negative 10 times negative 10 is going to make a positive 100. And then here, 4 cubed means 4 is going to be multiplied by itself 3 times. And whether you're using the parentheses or the multiply dot like we did in number 9 there, doesn't really matter. Although we tend to get away from using the dot. Parentheses are a little more appropriate as you go further along in algebra, although they're the same. Okay, so either way, 4 times 4 is going to make 16, and if I multiply by that third 4, I end up with my final result, which is 64. And this can be done in your calculator as well. So if you don't feel like multiplying 5 by itself 3 times, or negative 5, you're going to put negative 5 in your parentheses, and then you're going to use the little AB button, a to the b power button, to make an exponent, and then we're going to put that exponent of 3 in, and it will evaluate for you. And this is handier if it's a larger power, like negative 5 to the 7th. I'm not trying to multiply negative 5 by itself 5 times to find that value, so the calculator would be happy to give it to you. Okay? And there it is. That is it, I think. No? Oh, geez, no. Look, that's just multiplication. We haven't even done any division, have we? Oh, no, okay, I'm losing it, people. That's just the same page over and over and over again. I'm not sure why I have the same page in there 18 times. Okay, so I guess that is it. We did do division. We worked it in there, right? Yeah, guys, I'm losing my brain. Okay, so sorry about that. 2 pages, multiplication, division, and then some exponential notation, which is, again, just multiplication. You've got some practice to work on, and if you haven't lost your brain like I have, hopefully it will go okay for you. But as always, if you need some extra help, then just reach out. All right, till next time, take care.